Hello. What I want to discuss in this video is how you might go about resolving a mechanism. And in this case, it's the mechanism for our STEM kit in a box project. So on this module, what you're looking at is developing a mechatronic STEM kit that can be posted out to users. This game is going to be about attacking a castle, and what you are designing is you're designing the siege equipment to fire mechanically, and you will be designing an electronic trigger mechanism, hence making your mechatronic project. However, in parallel to you designing this for your project, I will be designing the castle, and what I wanted to do was discuss how I go about doing this over a quick video series so you can see how I would approach a project like this. Now, what we want is we want to have a castle, and this is one of the final pieces of it, that gets knocked down by your siege weaponry. So what we're looking to do is have this piece of castle fall over in some way to allow you entry. And in order to do that, I want a mechanism that will move it. Now, movement is probably going to be linear, and I'm either going to want that movement to be vertical up or linear forwards to either push over the castle or launch the castle. So the starting point for this for me was to do an internet search. Look for existing mechanisms, because honestly one of the best things you can do is find an existing mechanism and modify it to your needs. In mechatronics there's no point reinventing the wheel. So one of the first things I found was this. It was a lovely 3D printed kit that I bought offline for a Minecraft TNT block. You print the pieces flat, and then through these really great assembly instructions you create the Minecraft block, and what then happens is you press the trigger and it explodes. This explosive movement was exactly what I was thinking of, and one of the reasons for showing this resource is to give you, the student, a good idea of what good instructions look like. Now what this uses is essentially an over center cam, so the parts lock in place, and then when you press the trigger, he says about holding the bottom, the elastic bands contract and create outward force. So as long as I don't block it, that's what we're creating. And my honest initial idea was to have something like this, where it sits on it, and then when triggered, the castle wall explodes. What you've seen there is one of the first challenges, and one of the first challenges is this project binds. You actually don't get that much strength with this in an outward motion because the arms are quite easy to block and lock. There's quite a lot of friction because it is a 3D print, but it's quite a nice impressive explosion, but that explosion is very much moving in the vertical plane. The power is pulled that way and the damage is radial. So quite quickly I decided it's a lovely little mechanism, it's possibly not what I'm looking for. So the next thing I looked at, in all honesty, was a mousetrap. And the reason I looked at mousetraps are I can set up walls above a mousetrap, and then, utilising something that isn't my finger, when I set it off the parts move quite quickly. Now this honestly is a very cheap wooden mousetrap, and if we look at this, the challenge with it currently is the direction of force is down. So if you're looking at the wall, the force would want to go in this plane moving down. And the real challenge with that is, honestly, we want the weaponry to come in at an angle. If we're using a bolt thrower, a ballista, a catapult, it's going to come in towards it, not necessarily down. And that's why, when looking at the trigger like this isn't always the best mechanism to use. That being said, you can set up a mousetrap with a larger plate on the front, and with this larger plate, he says, you have a vertical target that when hit triggers the spring mechanism. This version that I'm showing you is actually the third prototype of this. So what I started was I started with a cardboard target, really quickly cut out and really rough. You can probably, if you hold it up, see the glue marks on it where it was hot glued to this. And you can see the damage on the back from where this striker has been striking it. And that worked incredibly well as a target. So what that did was allowed me to, he says, struggling to set up this trigger, have this over the wall, and then when fires, you get that vertical explosive movement. From there, I had moved to a plastic product, although at 1mm it was a bit flimsy, so I decided to try a water jet cut part. This water jet cut part goes on here, and it was a steel target that was made for robustness. Again, third prototype. Now what you'll see with this, being completely honest, is if I let go, quite a lot of the time it will set itself off. It had too much weight, and that was a real problem because this is a hair trigger. We've already bent it out of shape, and actually that forward momentum, that momentum wanting to lean this way, sets off the trap because it releases the triggering pin and it goes. So the next stage that I thought was, let's measure this up, get some quite accurate measurements on this, and let's water jet out some parts to make our own trap. And this was my first attempt at this. So I water jet cut out the parts, I started setting it up, and what I quite quickly realised with that third prototype was the triggering pin on this has a, come up here, it says, has a slight angle that raises up in that plane, as does the triggering latch on here. So again, get it in focus, this latch has a return, and that return that way and the pin up are what create that latch for then this to trigger and it to fire. Because of the additional weight in this, because of the inelegance of how I was making it, because of the increase in wire thickness due to materials, this prototype never worked. But what you are seeing now for this project is that we've moved from one mechanism to two mechanisms. On this mechanism we've gone from a cardboard prototype to a plastic prototype to a metal prototype, testing it to the point of failure. Now this part has failed, we've tried engineering our own part. In engineering our own part, we've reached another point of failure, but that's the fourth iteration we've got, and we start moving towards what is the final iteration of this project. And the final iteration that we will actually use in your testing is, again, a mousetrap, but a more robust model. And the reason for this more robust model is, just like every other mousetrap, it triggers and works, but there were two features that I really liked about this model. One, because of how the trigger mechanism is set, with that trigger going across the top here, if we were to add a vertical target to it to be triggered, one thing we have is a lot of mounting points around here, and the second thing we actually have is a counterbalance point here. So any weight I add to the front of the trigger, through the pivot point I can add to the rear of the trigger, and by adding weight here I can balance it out, so if I were to use another heavier metal target to make it more rigid, I could then quite simply add more weight at this point, and by adding more weight at this point I can have that balance across my pivot point. The other reason for using this is this bent wire at the moment is triggering a horizontal movement this way, so I am knocking my wall over and out. I can bend this wire relative to this wire, because this is your trigger wire and this is your trap wire. I can pull this further back, making the movement more vertical, or I can move it further back to have more of a strike to knock my wall further forwards. So this actual product has a lot more versatility, and that's what you're going to see in the final wall mechanism. But what I wanted to show with this is, honestly, when coming to solve a mechatronic problem, one of the things that I would strongly recommend is finding existing solutions. He says, test them in your scenario, iterate around them to see how they can work, and resolve it for the best, most adaptable solution for your project. So hopefully through this what you've seen is the evolution of how the triggering mechanism has worked within this game system. In next week's video, what we're going to talk about, what we're going to show you, is how actually the walls evolved within this. So obviously as part of your project, you're making a mechatronic bolt thrower. That's going to have the mechanical parts, this, the electronic circuitry that you're going to look at and program, and that's going to be fired at this castle defense. In my side of the project, we have the mechanical triggers for firing, for destructing your wall, flinging it away. We're then going to have the wall elements and what that looks like, because that's the integration for me between the mechanical system and the movement to create the game. And then after that, what we're going to look at in the third video is how we resolve that down into a packable product that can be posted, because that is the third part of your project. So thank you so much for watching, and next week we'll show you how we actually develop the game and talk through how you would design a game and a project.